Recording in progress.
So today we are going to start the box plot. Now already you know how to find quartiles for a data set. So we discussed our first chapter, descriptive statistics, and this is the last section of the first chapter. The topic was measures of variability. There are some measures we use to measure the variability of a data set, like range, variance, standard deviation. Likewise, we have a lot of measures of variability. And we last week we discussed how to find quartiles. Using quartiles also we can give a measure of variability. Okay, so if we have a data list called quartiles, and these quartiles divide a particular data set into 4 equal parts. Okay, Q1, Q2, Q3 are those quartiles. Now let's see how to construct a box plot using these quartiles and minimum and maximum values. Okay. In your ovals, you know how to draw this box plot, no? Right. To draw a box plot, we should know 5 measures. One measure is minimum value of the data set and the maximum value of the data set, and those 3 quartiles of the particular data set. If we know these 5 measures, we can easily draw a box plot for a distribution or for a data set. So why we, can anyone tell me why we use this box plot? What is the purpose of drawing a box plot for a data set? Why do we draw a box plot for a data set? Actually, if we know a data set or if we have a data set, we can find mean, mode, median, or variance, standard deviation, range to represent our data set or to get an idea about the data set. Okay, let's say we have a box plot for a particular data set. Let's say, so if we know the box plot, or if we can find, or if we can draw a box plot for a data set by looking at the box, we actually get an idea about the data set. We don't need to find, if we know the box plot for a particular data set, using that box plot, we can give an, or we can get an idea about the data set. First, I will show you box plot, okay, drawn for a particular data set. I know you are familiar with this box plot. So this is how we draw a box plot when we have a data set. First, we need to create an appropriate scale along the horizontal axis. You know, this axis represents the horizontal axis or x-axis, you know, that straight line, and draw a box extending from the first quartile to the third quartile, Q3, and the height of the box is immaterial. Actually, first of all, before constructing a box plot, there are 5 measures that we should know about the distribution. First one is minimum value, this one, and the maximum value. Okay, and those 3 measures called quartiles, Q1, Q2, Q3. You know how to find these measures for a distribution or data list. Okay, therefore, if we want to construct a box plot, first we need to create an appropriate scale along the horizontal x-axis. So appropriate scale means we have these values, no minimum value, maximum value, and their quartiles. So we need to mark those values on this axis. Therefore, we need to create an appropriate scale. Okay, then Q1 to Q3. Q1 is first quartile, Q3 is third quartile. And the height of the box is in material. You can take any height for this box. Okay. Now inside the box, you have to draw a vertical line, this line, to represent its median. So it's very simple to draw a box plot. I will give you an example or give you an exercise to draw a box plot. Please remember, for now, you should know only 5 measures: minimum, maximum, and 3 quartiles. If you know these 5 measures, you can easily construct a box plot using those 5 measures. Okay, keep in your mind. Okay, that is called box plot. Let's move on to the next topic, interquartile range. The definition is given as Q3 minus Q1. That means the difference between the third quartile and the first quartile. You know how to find Q3 and Q1 for a particular data set. Okay. If you are in a lecture, please mute your microphone, right? Otherwise, you are disturbing us. Anyway, we were discussing about interquartile range. The notation is IQR. IQR is different from the range. Okay, you know the range is defined as the difference between minimum and the maximum. No, it gives an idea about the size of the data set or distribution. But IQR is different from that. IQR is defined as the difference between the third quartile and the first quartile. Okay, Q3 minus Q1. So consider this example. You have to construct a box plot and find the IQR for the data set we considered in the previous example last week. Okay. Here I have given you those 5 measures. Okay, I'm not going to calculate those values again. Using these 5 values, you have to construct a box plot. As I told you earlier, if we know these 5 measures, minimum, maximum 1, Q1, Q2, Q3, we can easily draw a box plot for a data set. Okay, we have found these values. We have found these measures for the data set we considered in the last problem. Okay. So can you construct a box plot using this data? Can you? Okay, I will teach you how to draw that. Give me a second. So these are the measures that we know. First, we need to create an appropriate scale along the x-axis, horizontal x-axis, right? So here I'm marking the minimum value, that is 1.39, or we can write it as x mean. That should be x max, no? The last point, x max. Or you can write it as 1.39 and 4.0. And in between these two values, definitely these Q1, Q2, Q3 should lie. Okay. Now I'm going to draw the box plot. Now Q1 is 1.865. 1.865. if we divide this line into two equal parts, that value should be around 2, no? Okay, around 2. 1.865 should be some 65, and 3.4 should be somewhere here. That is Q1 and Q3. Then the median. What is the median? Median is 2.62. It should be somewhere here, no? 2.62 Q2. Now we have marked all 5 measures on the x-axis or on the horizontal axis. Now we are going to draw the box plot for this data set. Here, I told you the height of the box is immaterial. You can take any value for the height of this box. But when you mark these points or mark these measures, you should be very careful. To denote the median, we use this vertical line. Okay, so this is called box plot. In Sinhala, we say the term kotu kendi satahana. Okay, so here we have drawn that box plot for this data set. Okay, is it clear, guys? How to draw a box plot if we have a data set? If you have any question regarding the box plot, please ask me. Do you have any questions, guys? Please tell me yes or no. I'm not going to take much time today because I know this is the this is not a good time for conducting lectures. So this is person season. Anyway, I have to cover this small section because I want to finish chapter 1 today itself. That I took this 1 hour lecture. Most probably tomorrow you will not have lectures because I have my personal work. For tomorrow's lecture, I will arrange another 2 hour lecture, maybe within this week or next week. Okay, right. So if you don't have any question regarding the box plot, we can go forward. So this is a special or important topic, that is coefficient of variation. So if you can remember, I told you if we have 2 data set and if we want to compare those 2 data sets, how we are going to compare those 2 data sets. I just discussed with you how to compare 2 data sets with their mean values or with their variance values or variances. Okay, now we are going to compare 2 data sets or 2 variables using their coefficient of variation. Coefficient of variation, it's a coefficient, right, found from the mean value and the standard deviation, and it gives a percentage value. Here I have given you a brief introduction about the coefficient of variation. The term is defined as the ratio of sample standard deviation to the sample mean. You know, this is the ratio of sample standard deviation to the sample mean. Actually, usually we find this coefficient of variation for sample data, but there are some cases where we we need to find population coefficient of variation. It depends on the data set we have, but usually we find this coefficient of variations for sample data. If we have a sample, so using that sample, we can find coefficient of variation to compare 2 or 3 data sets. Okay, right. So it is defined as the ratio of sample standard deviation to the sample mean times 100. Here we multiply this ratio by 100 to get a percentage value. Okay, that is only the, I mean, it's a coefficient, and here I told you we represent that coefficient as a percentage. That is why we multiply that ratio by 100. Okay, right. Now come to the next point. It measures relative variation. You know, it is relative. The variation, this coefficient of variation is relative because it's a ratio. No? It's a ratio. S to the x bar, the standard deviation to the sample mean. Right? It always in percentage value, and it shows variation relative to mean. Yes, here we can understand that the sample standard deviation is relative to mean because it is the ratio of sample standard deviation to the mean. Mean එකට තමයි ඒක අනුපාත වෙන්නේ. S over x bar. S over x bar. Right? And it can be used to compare 2 or more data sets measured in different units. That's a special thing. Let's say we have a data set of 2 data sets of 1 variable. Okay, we have 2 data sets of 1 variable. In that case, we don't need to compare. Sometimes we may need to compare their coefficient of variation, but actually if we have 1 variable with, if we have 2 data sets with 1 variable, we can compare their mean values or variances. Okay. Please remember, if we have 2 data sets measured in different units, different variable, okay, in that case, we have to use this coefficient of variation to compare those 2 data sets, since we have 2 different variables. If we have only 1 variable, but we have 2 different data sets, but the variable is same. Okay, in that case, you can compare their mean values or variances. It depends on the problem. But if we have 2 data sets with 2 variables, okay, 2 data sets with 2 variables, 2 different variables, definitely we have to choose this coefficient of variation as the method to compare those 2 data sets. Is that clear, guys? Okay, I have given you an example. Please read this example. The following table gives the values of mean and variance of 2 variables, heights and weights of GCE O-level students of a certain school. Right? So here I have given you this data after summarizing. Okay. The question is, which variable has more variability than the other? Justify your answer. Now, try to understand the data we have first. Do we have 2 data sets or 1 data set? What do you think? Here, we do not have a data set actually. We have a table. Okay, in that table, it includes mean values and variances of 2 different variables, height and weight. For example, if you take 10 students of a particular school, okay, if you take 10 students, we measure their heights and weights separately. First, we measure their heights and then we measure their weights. Okay. after measuring their heights, we can find their mean and variance, and those two measures for the weight as well. Okay. Now the mean and the variance has been found as for the height 155, and that is the mean. Variance as 72.25 square centimeters. Okay. And please look at the units of these variables. First variable is height. No, the unit is centimeters. But in this, you can see that in second variable, the unit is kilograms because it is weight. Weight is measured by grams, kilograms. No. So here we are going to compare their means and variance of two different variables. They have different units. If both variables are same, let's say both variables are centimeters, I mean the units of the variable is centimeters, then no need to find their coefficient of variation. The comparison of variances is enough. But here we have two different variables, two different units, centimeters and kilograms. How can we compare two different units? How can we compare two different units? Usually we compare the same units. No? If you take two persons, we can find which one is tall one or short one by comparing their heights. Height in centimeters or meters, right? If you take two persons and if we are going to compare their weights, there also we are comparing the same unit, kilograms or grams. But here we are comparing centimeters and kilograms, two different units. So try to understand, when we compare two different variables, two different units, we have to consider this coefficient of variation, that is what? S over X bar. S over X bar times 100. It's a percentage value now. Okay. Here I have not given the answer. Let's do that together. Okay. Give me a second. 155 centimeters, 72.25 square centimeters. Then the 46.5 kilograms, 28.09 kilograms. Right. Now tell me, what is the question? Which variable has more variability than the other? Okay, we need to find the variable which has more variability. Variability එක වැඩිම variable එක තමයි හොයන්න යන්නේ. That may be either height or weight. Okay, right. Let's find it in this way. Okay, I hope you can see my screen. Now there are two different variables, height and weight. First, consider the variable height. Okay. The coefficient of variation for the variable height is what? S over X bar times 100. Now what is S? S denotes sample standard deviation. Here we are given the variance now, 72.25. So we need to get the square root of that value to get the sample standard deviation divided by X bar. What is mean value? Mean of the height, 155 centimeters. Here also centimeters. Why? We are getting the square root now. Therefore, 100, square centimeter becomes centimeters. No need to put that unit here. Centimeters cancel out now. Then times 100. You have to multiply that term by 100. Now tell me what is the value of this square root of 72.25 divided by 155 times 100. Tell me the value. Hurry up. What is the value? You can use your phone as a calculator. Oh, better to keep a scientific calculator with you as your technology students, especially electrical and electronic students. You may have to buy a scientific calculator. It would be better. Others also, if you can buy a scientific calculator, then it would be actually better. Otherwise, you can use your mobile phone as a scientific calculator. In the examinations, in my examinations, I will provide calculators for you. Okay, did you get the answer? I'm not going to find it because now I don't have a calculator. I have one, but now I didn't bring it here. Okay. While you are finding that value, I'm going to find the coefficient of variation for the variable weight. That is S over X bar is defined as square root of the variance. Therefore, the value becomes 0 by 46.5 times 100. Find these two values quickly. What is the value, guys? There are 22 students. Did anyone find that value? Yes or no? Is it 5.48? Yes or no? The second value
0.54.
0.54. Yes, 0.54 is square root of 72.25 divided by 155. You need to multiply that term by 100 to convert a percentage value. Clear? 0.54 is correct. It may be correct. Anyway, the final answer should be 5.48. The second value must be 14.913. You can write it as 14.91. Are these two values correct? Is that correct, guys? Tell me. The ratio between the ratio of these two terms must be 0.054, and if you multiply that term by 100, finally you will end up with 5.48. So if you find the coefficient of variation for the variable weight, that would be 14.91. After getting coefficient of variations for both height and weight variables, you have to compare these two terms because we need to find the variable which has more variability. Okay, so which one is the variable? Yes, which one is the variable with highest variability? Height or weight? Now we have found the coefficient of variation. The variations to the or the standard deviation to its mean. 5.48 and 14.91. So which one is the variable with highest variability? Which variable? That should be 14.91, because if you compare these two, coefficient of variation for the variable height, 5.48, and it is less than coefficient of variation of weight, that is 14.91. Since this is the highest value, weight should be the more varying variable, or weight should be the most varying variable, or you can write the conclusion as the weight is the variable which has highest variability compared with the height variable. Okay, here you are comparing your height with weight. Okay, you're comparing this height and weight. Therefore, when you write the conclusion, you should write the weight is the variable which has highest variability compared to the variable height. Is that clear? Because the coefficient of variation of height is less than coefficient of variation of weight. So if you are asked to find a consistent variable, most consistent variable, how we are going to find that variable? In this example, you are asked to find the variable which has more variability, right? So if you are asked to find the variable with more consistent, how we are going to find most consistent variable in these two variables between height and weight? How we are going to find it? The same method, you have to compare two. Therefore, you have to compare their coefficient of variations. You can see that the coefficient of variation of this 5.48 is less than 14.98. So 14.91. This 14.91 has the highest variability. But we need to find most consistent variable now. In that case, we need to pick the height. Why? We need to select most consistent one. Consistent means the variability of variance must be less value, higher value. Understand? With the highest variability, then we need to find the highest coefficient of variation. If we want to find the most consistent variable, we need to pick the not the highest coefficient of variation, but the less coefficient of variation. Okay, so between these two variables, height and weight, height is the most consistent variable. But in the question, We are asked to find the variable with more variability. No? Therefore, answer for this particular problem is what? Weight. Weight has more variability than the height. Understand? Yes or no? So it's really important to interpret our results. Interpretation is really important. So you, if you have a calculator and if you have a data set, you know how to find these coefficient of variations, mean values, variances, you know. But comparison or the conclusion is important in statistics. Right. I hope you all understood how to find coefficient of variations for different variables. So I'm going to start the next topic, measures of skewness. I think once I discussed with you about the skewness of a distribution, here I have given you sketches as well. Measures of skewness, the statistical technique to indicate the direction and extent of the skewness in the distribution of numerical values in the data set. Okay, let's say we have a data set, right? That data set is numerical. That means we have quantitative data, not qualitative. For those quantitative data, we can find a histogram or we can draw a histogram. No, I told you how to, I taught you how to draw a histogram for a particular data set, right? So, and again, I mentioned when the number of elements in the sample or number of elements in the distribution is getting a higher value, getting large, then the histogram becomes a curve finally. So that curve is called simply a distribution. Okay. There are three types of distribution: symmetric, skewed. That skewed may be positively or negatively skewed. Therefore, we have three types of distribution: symmetric distribution, positively skewed distribution, and negatively skewed distribution. Here you can see a graph. The middle one is very famous. It's popular. That's a normal distribution because it is symmetric about its mean, median, mode, measures of central tendency. So if you have a normal distribution, or if you have this type of distribution, it must be symmetric about its mean, median, and mode, and it should be in bell-shaped. The shape is bell-shaped. Okay, we call it as a symmetric distribution. But if you consider the first sketch, first distribution, that is different from the normal distribution. At glance, you can say that it's a skewed one. Then we need to find whether it is positively skewed one or negatively skewed one. So how we are going to find that positively skewness and negatively skewness, positive skewness and negative skewness? The Pearson has defined this coefficient of skewness. Pearson as a Pearson's coefficient of skewness. It's defined as mean minus mod divided by its standard deviation for a particular data set. If you find mean and mod standard deviation using these three measures, we can find Pearson's coefficient of skewness using this formula: mean minus mod over standard deviation. Okay, this measure always, this term always measures the degree of lack of symmetry. That means if we have a symmetric distribution, then definitely this coefficient must be 0. Neither. If we have a symmetric one like this, like the middle one, if we have a symmetric one, the skewness must be 0 now, because it is symmetric. In that case, mean minus mod equal to 0. if the distribution is symmetric, mean and mode are same. No, mean is same as mode. Therefore, mean minus mode becomes 0. Therefore, SKP is going to be 0 for a symmetric distribution. But if we have a skewed one, either it is positive or negative, this coefficient of, coefficient of skewness has a value. That value ranges from -1 to +1. It's a value in between -1 and +1. This SKP or Pearson's coefficient of skewness, mean minus mode over standard deviation. Okay, if we get a positive value for this, we call as positively skewed distribution. That's a positively skewed distribution. If we have a negative value for this SKP, then we call it as a negatively skewed distribution. Okay, let's go back to the diagram here. As you can see here, the right tail is very long now. If the right tail is very long, I told you we call it as positively skewed distribution. Or if you want to measure it, the skewness, you have to use the formula mean minus mode over standard deviation. So this has a positive standard deviation. But when we find confidence interval, we consider their negative and a positive standard deviations. But remember, we have a positive variance here. Therefore, we have to consider only the term mean minus mode. This part affect its negativity and positivity. No, neither. Mean minus mode affect the negativity or positivity. Therefore, we have to consider the term mean minus mode only to find its skewness, whether it is positive or negative. So mean minus mode. Let's go back to this diagram. So mean is somewhere here and mode is somewhere here. If you consider mean minus mode, mean is a higher value than mode. No. Therefore, mean minus mode gives a positive value. Mean minus mode. Is that clear? So here you have x-axis, no? In the first diagram. Okay, give me a second, I will explain it. Here, mean is somewhere here. Mode is highest, most frequently occurring value of mode is that should be here. So if you consider mean minus mode, definitely this should be greater than 0. Neither. Mean is greater than mode. Mean is greater than mode. Somewhere here. No? Since mean minus mode greater than 0 means this standard deviation. This term is also positive. Understand? Therefore, if we get a positive value, what we can say about the distribution is it's a positively skewed distribution. Okay, now we have this type, say, type of distribution. I told you, without calculating the skewness, you can say this is negatively skewed distribution, but we can actually find it. Here, mode should be somewhere here. The value corresponding to the peak, right, mode. Now tell me where the median, not median, mean lies. Mean should be somewhere here for this data set. Okay, that thing you should know. So if you consider mean minus mode, definitely it should be a negative value, less than 0, because mode is greater than mean. So if you write mean minus mod, that is less than 0, no? Understand? If you take this mod to here, mean minus mod becomes a negative value. Since mean minus mod gives a negative value, what about this term? Mean minus mod divided by standard deviation. That is also less than 0. If such a distribution, we call it as negatively skewed. Usually, if you consider, if we can take a large sample, right, we may have a normal distribution. When the size of the sample is getting large, really large, okay, usually the distribution becomes normal. But if you consider a small sample size, sample of small size, okay, then definitely that sample may be a skewed one, negatively or positively. That is why we always try to get a large sample for a research or for a survey or for an experiment. Okay, so if we can use large sample size, then definitely that is going to be a normal distribution. So if we have skewed distributions, we cannot compare their mean values, variances. Okay. So if we have skewed distributions, we have to go for the different measures like median comparison. I will teach you those things later. For now, please remember, if you have this type of distribution, that is called negatively skewed, since the formula is mean minus mod. Okay, if we have this type of distribution, that is normal distribution, it is symmetric about its mean, median, and mod, and it's a bell-shaped curve. If you have such a distribution or this type of distribution, it is called positively skewed distribution. You can see that the right tail is very long. If we want to explain their skewness, we can use the formula mean minus mod over standard deviation that is introduced by Pearson. So we call that coefficient as Pearson's coefficient of skewness. And other than this formula, he introduced another formula, okay? This one. I think I have not, yes, I have included the formula, measures of skewness, 3 times mean minus medians over standard deviation. The same person has introduced this formula, but usually we prefer the first formula to measure its skewness. Okay, therefore, in a problem, if you are asked to find measures of skewness, please use this formula, mean minus mod over standard deviation. But if we are going to use the second formula, you have the first formula introduced by the same person. Okay, so this is the end of the first chapter, descriptive statistics. As we have only 1 minute, I'm summarizing the whole chapter. First, we discussed the important terms of statistics, then measures of central tendency, measures of variability, and measures of skewness finally. So this is the end of the first chapter. If you have any question regarding the first chapter, you can ask me whenever. Okay, this week I will give you the first tutorial from this section. I will upload that tutorial to the LMS. Okay, if you don't have any question, I can wind up the session for now. Please remember, tomorrow, most probably, you will not have lectures from 1 to 3. I will send you an email about it tomorrow. Okay, right. Do you have any questions? Yes or no?